Good morning to everyone. Okay, so in the last class, we discussed about trapezoidal rule, and then Simpson's 1/3 rule, and then Simpson's 3/8 rule. Okay, now continuation of these three formulas. Now we are going to discuss the next problem. Okay. Okay. Before going to the next problem, Simpson's one-third rule you can apply for any number of intervals. The intervals may be odd, the intervals may be even. Okay. Okay. But for Simpson's one-third rule you can apply only if the number of intervals is even number of intervals. Otherwise, we can't apply Simpson's one-third rule. Simpson's 3/8 rule you can apply only if number of interval is the multiple of 3. So these are some of the restrictions for Simpson's 1/3 and Simpson's 3/8 rule. The next problem is a curve passes through the point 1, 2. It is the point is given 1.5, 2.4, 2, 2.7, 2.5, 2.8, and 3, 3.5, 2.6, and 4, 2.1. Obtain the area. Obtain the area. Obtain the area bounded by the curve. Area bounded by the curve, x-axis, and x is equal to 1, and y equal to 4. So that means, okay. So suppose the curve is like this. Okay. So bounded by the curve from here to here, and x-axis, this is x-axis, and x is equal to 1. This is x equal to 1. This is x equal to 4. Also find the volume of solid of revolution got by revolving this area about the x-axis. So for area, so this is the formula, integration a to b y dx. For volume, pi into integral a to b y square dx. Okay. Now you can see h is equal to 0.5 because 1, 1.5, 2, 2.5. So h is equal to 0.5. So now x value corresponding y values which is given in the question, which is given in the question. Okay. Now by using Simpson's 1/3 rule, rule, area equal to this is the formula, integration a to b y dx. A is what? A is 1, and b is 4, y dx. So Simpson's 1/3 formula is what? H by 3 into y0 plus yn plus 2 into y2 plus y4. That is even suffixes y2, y4, y6, y8 plus 4 times the remaining variables. That is which is not here, or which is not an even suffix, and it is not y0 and yn. Okay, that means y1, y3, y5. Okay, y7 and so on. Okay, now h is equal to 0.5, we know that, and the y0 value is what? 2. Yn is here y6, that is a 2.1 plus 2 into y2, y4. Next to y6, but y6 is here already, I wrote here. So y2 is what? 2.7, y4 is 3, plus 4 times y1, y3, y5. y1 is 2.4, y3 is 2.8, and y5 is 2.6. You can check it here, and using calculator you should simplify and get the answer 7.7833 square unit. So now Simpson's using 1/3 rule, I'm going to find the volume. The formula is pi into integration a to b y square dx. That is equal to pi into A to B. A is 1, B is 4, y square dx. So Simpson's one-third rule formula. One-third rule formula is h by 3. H by 3. Actually, y naught plus yn, but here you have y square. So you should write y naught square plus yn square plus 2 times y2, y4, y6, but here you have y square. So y2 square plus y4 square and so on. Similarly, plus 4 times y1, y3, y5. So you should write y1 square, y3 square and so on. So from the table, you can write the values for y0, yn, y2, y4, y1, y3. You should write from the table, and h is equal to 0.5. And to simplify, you will get the answer 64.13 cubic units. So this is some of the problems. So I think you can try, and if you have any doubts, you can ask the 3 problems. Okay, the first problem is evaluate the integral using 7 ordinates. 7 ordinates means a 6 interval, y0 to y6. From y0 to y6, you have 7 ordinate, so and hence it contains 6 intervals. 6 intervals means you can use all the 3 formulas. Compute the integral by taking h is equal to 0.2. 0.2 means 0.2 to 0.4, 0.6, 0.8, 1, 1.2, 1.4, using trapezoidal rule and Simpson's rule. So compare the results by actual integration. Okay, now only thing you should check it whether you have how many ordinates. 0.2, 0.4, 0. Actually 6, totally 7 ordinator. 1.0, 1.2, 1.4. So totally 7 ordinates. So 6 intervals. Okay, 1, 2, 3, 4, 5, 6. So you can use all the 3 formulas: trapezoidal, Simpson's one-third, Simpson's 383. Okay, now integration 1 to 1.4 e power minus x square dx square, dividing the range into 4 equal parts. 4 equal parts means 1.4 minus 1 divided by 4. You should divide by 4. That is equal to 0.4 divided by 4. That is using calculator. Okay, so you check it. That is find the value of h. This is actually h. So using this h, you can solve this problem using trapezoidal rule and Simpson's one-third rule. Okay, so try. If you have a doubt, you can ask me. So this is 0.1. So 1, 1.1, 1.2, 1.3, and 1.4. So there are 4 intervals. 1, 2, 3, 4. Okay, we have 4 intervals. So it is an even number. So then you can apply only Simpson's one-third rule, but you can apply trapezoidal rule, but you can't apply Simpson's 383 rule. Okay, for this problem, find the value of log 2 power 1 by 3 from the integral 0 to 1 x square dx by 1 plus x cube using Simpson's one-third rule with h is equal to 0.25. H is equal to 0.25 means 0, 0.25, and then 0.5, and 0.75, and then 1, 1, 2, 3, 4. So okay, so it should be even number of intervals. So you can use Simpson's one-third rule. Okay, here f of x is what? X square by 1 plus x cube. So using Simpson's one-third rule, you should find the value of this integral. So it is a question mark, you need to find out, but using the formula. Okay, but in the question they are asking find the value of log 2 power 1 by 3. Okay, for this, by actual integration, you need to integrate 0 to 1 x square dx by 1 plus x cube. So if you differentiate the denominator, you will get 3. You will get 3 x square. So 3 is not here. So divide by 1 by 3, multiply and divide by 3, and you can write that one is log of 1 plus x cube, log of 1 plus x cube. Okay, so if you substitute the upper limit, we'll get 1 by 3 into log 2, 1 by 3 into log 2 minus log 1 is 0. So 1 by 3 log 2, you can write log 2 power 1 by 3 using properties of logarithm. Okay, first you should write this is equal to 1 by 3 log 2 and then log 2 power 1 by 3. So now from 1 and 2, you can easily find the value of log 2 power 1 by 3. So whatever value you are getting from here, you can write here. Okay, log 2 power 1 by 3 equal to this value. Okay. So next problem. The velocity capital V, the velocity capital V of a particle at distance s, from a point on its path is given by the table below. The velocity v of the particle at distance s from a point on its path is given by the following table. So s in meters. Okay, 0, 10, 20, 30, 40, 50, 60. Here h is 10. Velocity v. Okay, velocity v is what? It is given. Okay, so estimate the time taken to travel. Estimate the time taken to travel 60 meters. Again, I'll repeat. Estimate the time taken to travel 60 meters by using Simpson's one-third rule. Okay, we know the relationship between velocity and the distance. So velocity v equal to ds by dt. So dt equal to 1 by v into ds. dt equal to 1 by v into ds. So if you integrate both sides, you get t equal to integration 1 by v ds. S varies from 0 to 60. So I'll take this 1 by v equal to y. Okay, so y, or otherwise you can keep just 1 by v. Okay, no problem. Okay, so I will take 1 by v equal to another variable y. This is just for substitution. Okay, otherwise you can keep as it is 1 by y also. Okay, now we'll go to the table. S is given the table 0, 10, 20, 30, 40, 50, 60. S is given here. And V is also given the table 47, 58, 64, 65, 51, 38. Okay, so I'm finding 1 by V. 1 by V is what? 1 by 47. That is 1 by V is Y. Okay, so reciprocal of 47, reciprocal of 58. So similarly, reciprocal of 38. So these values are Y0, Y1, Y2, Y3, Y4, Y5, Y6. Okay. Now Simpson's one-third rule. Okay, but here it is mentioned. Yeah, Simpson's one-third rule. Okay, so the interval length is what? Totally 6. 1, 2, 3, 4, 5, 6. So 6 is an even number. But even you can apply Simpson's 3/8 rule. But here only they are asking Simpson's one-third rule. Okay. Simpson's one-third rule is h by 3 y0 plus yn plus 2 times even suffixes plus 4 times the remaining suffixes. That is y1, y3, y5. Especially odd suffixes. Okay, it is better to tell odd suffixes because this is always even. This is always even number. It should be odd suffix. all the odd suffix y1, y3, y5. But here y6 will not come because here y0 plus y6 here. So here 2 into y2 start from y2 except the last one because the last one is coming here. So last one is always even number. Okay. So integral 0 to 60 because you can see here x0 is 0 and xn is 60, 0 to 60 y ds f of x. Okay, you can see here we are calculating 0 to 60. What is the previous table? Y ds. Okay, that is t. We are finding estimate the time. So t equal to integral 0 to 60 y ds. So where y equal to 1 by b. Where y equal to 1 by b. Okay, now I think I am explaining here. Simpson's one-third rule. Simpson's one-third rule. So integral 0 to 60 y ds. Y ds. That is t. That is t. This is t. You can check it in the previous slide. T equal to 0 to 60 y ds. Where y equal to 1 by b. Okay. Now h is for 10. 10 by 3. Y0 plus yn. Y0 plus yn is y6 plus 2 into y2 y4, that is 1 by 64 plus 1 by 61 plus 4 times odd suffixes y1 y3 y5. So this is calculator simplify and get the answer t equal to 1.06346. Okay. Next problem is the table below gives the velocity of a moving particle at a time t seconds. At a time t seconds, find the distance covered by the particle. Find the distance covered by the particle in 12 seconds, and also the acceleration at t equal to 2 seconds. Okay, again I'll repeat the question. So the table below gives the velocity of a moving particle at time t seconds. Okay, that is given. Velocity is given at a time t. We need to find the distance covered by the particle in 12 seconds. That is s. We need to find s. Okay, the distance covered by the particle in 12 seconds, and also the acceleration at t equal to 2 seconds. Okay, so acceleration means dv by dt, differentiation. Acceleration means dv by dt at t equal to 2. So numerical differentiation. We need to find the distance. Okay, so v is given. The relationship between v and s is v equal to ds by dt, and ds is equal to v dt. And if you integrate, you will get s is equal to, that is the distance, s is equal to integral 0 to 12 v dt, because t varies from 0 to 12. So to find s, we need to use numerical integration. To find acceleration, we need to differentiate v. So here in this problem, you need to apply both numerical differentiation and numerical integration. Okay, so s is equal to integral 0 to 12 v dt, and a is nothing but acceleration is nothing but dv by dt. Okay, so we need to find two things. One is distance covered by a particle in 12 seconds, that is 0 to 12. Okay, d dt, and acceleration at t equal to 2. Acceleration is dv by dt at t equal to 2. First we will find s. So here 1, 2, 3, 4, 5, 6. So you can use all the three formulas. It is better to use the Simpson's one-third formula. Simpson's one-third rule is integral x0 to xn f of x dx is equal to h by 3 into y0 plus yn plus 2 into y2 plus y4 and so on, plus 4 into y1 plus y3 and so on. So s is equal to integral x, we know that x is equal to integral 0 to 12 v dt, okay, and for this I am going to use Simpson's one third. H is equal to what? H is equal to 2. H is equal to 2 by 3 into y naught plus yn. Y naught plus this is y naught, y1, y2, y3, y4, y5, y6. That is 4 plus 136. 4 plus 136, and then plus 2 into y2, y4. 2 into y2 plus y4. This is y2, this is y4. So 16 plus 60. 16 plus 60 plus 4 into y1, y3, y5. y1 6, y3 y1, y3, y5. So 6, 34, 94. 6, 34, 94. So this you call C, you can simplify and get the answer. It's a 552. So next one is Newton's, because we need to find the acceleration. Acceleration is dv by dt. So I am going to use Newton's forward difference formula to get the derivative. So A equal to dv by dt, that is equal to, using Newton's formula, 1 by h. Usually we say delta y naught plus 2u minus 1 2 factors. Instead of v, we are using y naught, okay, and it u equal to x minus x naught by h, but here t minus t naught by h. Okay, this is Newton's forward difference formula. Already we discussed this formula. Now only thing we need to find the value of u. Okay, u you can get it from this, but t is what? It is given the question. T is 2, t naught is 0, t naught is 0. Common difference is 2. H is 2. T is 2, t naught is 0. So t minus t naught, 2 minus 0 divided by 2. That is 1. So u equal to 1. So if u equal to 1, substitute u equal to 1 in this formula. So 1 by h, delta v naught, u equal to 1 means 2 minus 1 is 1, 1 by 2 into delta square v naught. 1 by 2 delta square v naught. And then here u equal to 1. So 3 minus 6 plus 2. So 3 plus 2, 5. 5 minus 6, that is minus 1 by 3 factorial. So minus 1 by 6 into delta cube v naught. Minus 1 by 6 delta cube v naught. Okay, and then we need that a table also, because we need to find what is the delta v naught, delta square v naught, and delta cube v naught. So we know that t values and v value, that is given the question. So you know how to form the table. That is delta v equal to what? 6 minus 4, 2. 16 minus 6 is 10. 34 minus 16 is 8. So similarly, you can find delta square v naught. 10 minus 2 is 8. So if you do it, everything 8 means here everything is 0. Now acceleration is equal to dv by dt at a t equal to 2 equal to h is equal to 2. So 1 by 2. Delta v naught is 2 plus 1 by 2. Delta square v naught is 8 plus delta cube v naught is minus 1 by 6 delta cube v naught, that is 0. Simplify and get the answer. Okay, that is the answer is 3 meter per second square. So this is the final answer. So next method is the Romberg's method. So the Romberg's method is repeated application of trapezoidal rule. Okay, this is not a new one. So here I am going to use trapezoidal rule many times. So I will explain you. Only thing you should remember this formula: I equal to integral x naught x1 f of x dx is equal to I2 plus 1 by 3 into I2 minus I1. Where I1 and I2 are the values of I got by two different values of h by two different values of h. by trapezoidal rule. Yeah. By applying trapezoidal rule many times, every time halving h. So suppose h is 0.5 first time, we should divide the h by 2 for the next time. We get a sequence of values. Okay, I will explain through the problem. Evaluate interval 0 to 1 dx by 1 plus x square by rhombus method. Hence, obtain an approximate value of pi. So here f of x is equal to 1 by 1 plus x square. Okay, and h is equal to b minus a. I am taking n equal to 2. Okay, now I am taking n equal to 2. Okay, so 1 by 2 is 0.5. 1 by 2 is 0.5. So x value is 0, h is 0.5. So x 0, 0.5 and 1. And the corresponding f of x value, we know that f of x is equal to 1 by 1 plus x square. So substitute x equal to 0. 1 by 1 is 1. And substitute x is equal to 0.5 here. 1 by 1 plus 0.5 whole square is 0.8. So similarly, substitute x equal to 1 here. So 1 by 1 plus 1 is 1 by 2, that is 0.5. Now, using trapezoidal rule, you know that the formula h by 2 into y naught plus yn plus first value and last value plus twice the remaining values. Okay, that is equal to h is what? 0.5 divided by 2. Y naught plus first value and last value 1 plus 0.5 plus 2 into remaining values. Remaining value is only 1, 0.8. So I am getting the value 0.775. Okay. Now, last time h value is what? 0.5. Now, next time I am going to divide by 2, halving h value. So you'll get h is equal to 0.25. So you know that starting value and ending values are 0 and 1. So h is 0.5. So 0, 0.25, 0.5, 0.75 and then 1. So correspondingly f of x value. You know that f of x is 1 by 1 plus x square. Substitute x equal to 0, 0.25, 0.5, 0.75 and 1. Okay, I got the table value. Again, you should use the trapezoidal rule. On h by 2, first value plus last value plus 2 times the remaining values. So h is, we know that the latest value of h is what? 0.25 divided by 2 into 1 plus 0.5 plus 2 times 0.9411 plus 0.8 plus 0.64. So I got this value. Okay. Now, again, what is the previous h value? Previous h value is 0.25. Okay, 0.25 divided by 2. So 0.125. Originally it was 0.5, and second time 0.25, third time 0.125. Okay, so now for this h value, again form the table 0 to 1. Corresponding f of x value you should write. And again, as usual, apply trapezoidal rule. First value plus last value plus 2 times the remaining values. I got 3 values. So this is the first value, this is the second value, this is the third value. Okay, now listen here. So first you should take first value and second value. So you take, this is I1, this is I2. Okay, so forget about this I1 and I2. Okay, this is I1 now, this is I2. I already told that Rampus formula is already told that I2 plus 1 by 3 into I2 minus I1. Okay, what is I2? I2 is 0.7827. This is I2. 0.7827. Okay, plus 1 by 3. Again, I2 is 0.7827. I1 value is what? 0.775. 0.7. So I got one value. I will take that value is I1. Okay. Now again, I equal to I2 plus 1 by 3 into I2 minus I1. The same formula. But now this time we should take this is I1. This is I2. Okay. Last time you are taking I2 is now this time I1. Okay. So this is I1 now. This is I2. So I2 is 0.7847. Okay, so you can see here 0.7847, and 1 by 3 again I2 is 0.7847 minus I1 value. I1 value is 0.7827. 0.7827. Now I got the value 0.7853, that is I2. Using this I1, I2, now I am going to improve the value of I equal to I2, again the same formula, I2 plus 1 by 3 into I2 minus I. What is now I2? 0.7853. 1 by 3, I2 is 0.7853 minus I1. I1 is 0.7852. So simplify, I got 0.7853. So you can stop here. So therefore, we are evaluating interval 0 to 1 dx by 1 plus x square using numerical integration, that is equal to 0.7853. Okay. By actual integration, this is nothing but tan inverse of x. The limit is from 0 to 1. So upper limit minus lower limit. So tan inverse of 1 minus tan inverse of 0. Tan inverse of 1 is pi by 4. Tan inverse of 0 is 0. So pi by 4. From 1 and 2, the left hand side of 1 and 2 is same. So then you can equate the right hand side of 1 and 2. That is pi by 4 equal to 0.7853. So pi is approximately equal to 3.14. Okay. Now, so this is a RMS value. Okay. This is RMS value. Using this RMS value, there is one application column. So RMS value is integral root of I think you studied in the third semester also, RMS root mean square value is root of integration a to b y square dx by the difference between the length of the interval, that is b minus a. Okay. Now this is okay, some of the columns. The screen is the screen is visible for you? What about this? Okay. So this is RMS value. That is the root of a to b y square dx divided by b minus a. First, I will explain this part and then I'll go to the previous slide. So to find I, integration 0 to 1 by 2, 10 into e power minus t into sine 2 pi t whole square dt, where t equal to 1. When t equal to 1, okay. So where I of t equal to 10 into e power, actually this is the general formula, okay, general formula for the current I of t equal to 10 into e power minus t by capital T into sine 2 pi t by t if t lies between 0 to t by 2, the current is equal to this value. When t equal to t by 2 to t, the current is 0. Okay. Now, if we substitute t equal to 1 here, uh, you'll get, here, I will write here, uh, t equal to 1 means 0 to 1, because t equal to 1. 0 to 1, because here 0 to 1 by 2, here 1 by 2 to 1. So 0 to 1. Okay. I of t, I'm writing this I, capital I. Okay, capital I equal to 0 to 1, I of t square dt. So actually this is the formula. Now, now 0 to, you should split into 0 to 1 by 2, 0 to 1 by 2, I of t square dt plus 1 by 2 to 0, sorry, 1 by 2 to 1, by 2 to 1, I of t whole square dt. So in this interval, I of t is what? 0. So remaining you have this interval 0 to 1 by 2, I of t. Okay, I of t is nothing but 10 e power minus t by capital T, but the capital T is, we know that 1. So 10 into e power minus t, you can check it here, 10 into e power minus t sine 2 pi t whole square. Okay. Now, trapezoidal rule. So t value I am originally t value is 0 to 1 by 2. So I am taking h is equal to 0.1. 0, 0.1, 0.2, 0.3, 0.4, 0.5. So 0 to half. This is a t is ranging from 0 to half. Okay. Now, I of t square I need, because this is I of t whole square, I of t square. Where I of t is what? Where I of t is 10 into e power minus t into sine 2 pi t. So 10 into e power minus t sine 2 pi t. This is I of t. I need I of t square. So now using calculator, please check it. If you substitute t equal to 0.1 here, so 10 into e power minus 0.1 into sine 2 pi t. T is 28 point, sorry, t is 0.1. Whether you are getting 28.2865, please check it using radian mode. Please check it at least one or two and verify the answer. Okay, otherwise you verify. If you don't get it, you can tell. Okay, now once you form this row I of t whole square, next you should use the trapezoidal rule, h by 2 into y naught plus yn plus 2 times remaining values. H is 0.1 divided by 2, y naught is 0, yn is also 0 plus 2 times the remaining values. So I got it 15.40819. But I need RMS value. RMS is what? RMS is integral 0 a to b y square dy divided by b minus a. Divided by b minus a. But here b minus a is here you are taking t equal to 1. T equal to 1. So 0 to 1. Originally we are taking what? 0 to 1. So b minus a is 1 minus 0 is 1 here. For our problem, b minus a is 1. So integral 0 to b y square dy. Instead of y square, I have I square. I have I square. So only thing we need to take the root. Okay. So we need to take the root of the value 15.40819. I get the RMS value. Suppose we wish to find Simpson's one-third rule, we need the interval is 6. We need total number of interval is 6. So B is 0.5 and A is 0. I am dividing by 6. So H is equal to 0.0833. So using this H, you should form the table. Okay. So 0, 0.0833 and so on. But the last value is 0.5, that is half. So before that I have 0.4998. If I add again the H value, it will exceed 5. So that's why I'll stop here. So next you should find the corresponding I of t whole square value. So use Newton's Simpson's one-third rule. Simpson's one-third rule is H by 3 y naught plus yn plus 2 times even suffixes plus 4 times odd suffixes. So using table, you should find the value of this integral, that is a 15.4226. And then I need a RMS value, so take the square root. I got 3.927. Okay. Now I'm going to give a problem to you. Okay. So please write down. Find the area common to the circle. Common to the circle, x square plus y square equal to 4. And the ellipse x square plus 3y square equal to 6. By numerically integrating numerically integrating integrity in the region by trapezoidal rule. Using at least 6 ordinates. Solution. So there are common area to the circle and ellipse. Okay. This is x-axis. This is y-axis. So this is the origin. Okay, now this point I'm taking B. B is 2, 0. B is 2, 0. Okay, and then okay. This is F. This point is F. This portion is E. From here to here, E. So this point is D. D. This is the intersection of this point. D is the intersection of ellipse and circle. So please solve these two equations and check the values of x and y. That is √3, 1. So you can verify later. So D is √3, 1, and this portion, this arc is C. This arc is C, and I'm going to draw a straight line. Yeah, this is a straight line. Okay. Okay, it's not looking as a straight line, but it is a straight line. This point is A. This point is A. Okay, now the common area. So required common area is equal to the required common area is the you can see here the shaded portion. And similarly in the first quadrant also I will share later. Okay, now that is equal to 4 times area of O. Uh, this point is A. This point is A. O, B, and then C, this arc, and then the point D. After point D, there is an arc E, and then F point, and then O. So you should find the area of this region and multiply by 4. So that is the required common area. Now, instead of finding this, I am going to find that is 4 times area of O A, and then after A, through this straight line, I'll travel through the point D. From D to the arc E, arc length F, point F, and then again O, plus area of the remaining part. This part I found out. I will share some other color. I'll use yellow color. So area of O A D E F O. This is in yellow color area. So remaining area is, I'm going to give a black color. This one. Okay. So that is what? A B, the arc C, and then point D, again A. So once you understand this, you can easily do it. Okay, now next line, next page, equal to, this is 4 times area of this region, yellow region, that is OAD EFO, is equal to integral y dx, x varies from where to where? X varies from, here x is 0, here x is √3, because I told that this is a straight line. The point D is √3, 1 means A is √3, 0. A is √3, 0. So x varies from, in this yellow region, 0 to √3. X varies from 0 to √3 plus okay, now in this region, that is A, B, C, D, A. In this region, here x varies from A to B. Okay, A to B. In A, x value is what? √3. In B, x value is what? 2. So x ranges from √3 to 2. √3 to 2 into y dash. I will take y dash into dx. So we should tell where x square plus 3y square equal to 6, or this is an ellipse equation, or y equal to, or y square equal to, or 3y square equal to 6 minus x square, y square equal to 6 minus x square by 3, y equal to root of 6 minus x square by 3. This is y. Okay, so this y, because here x varies from what, 0 to root 3. So this is an ellipse equation. 0 to root 3. So here only uh, we can see that x ranges from 0 to root 3, and here x is varying, y is fixed. X is varying, y is fixed. But here we need to consider the equation of the ellipse, because here the points are touching the ellipse here. So next, and y dash, we need y dash. So and x square plus y dash square equal to 4, or y dash is equal to y dash square equal to 4 minus x square, or y dash is equal to root of 4 minus x square. This is y dash, this is y. So instead of y, you can use this expression. Instead of y dash, you can use this expression. So remaining thing, you will try, okay, using numerical integration, that is use Newton's trapezoidal rule. So using trapezoidal rule, find the value. So this is equal to, you can write 4 times a1 plus a2, where a1 is this integral, a2 is this integral. So here 0 to root 3, here root 3 to 2. Okay, here y is given here. For x is equal to 0, you can find y, this y. So, but you should divide the interval into, but you can divide into any number of intervals, at least 5. At least 5. Okay. So if you have any doubts in the, especially in the last problem, you can ask me now or you can ask later. Otherwise, we'll meet on next Monday. Okay, thank you.